So in the last video, we talked about the basics of polynomials. And this one, we are going to classify the polynomials. So we are going to have our next question where we will classify the polynomials. On the basis of degree and terms. So in the last section, we were looking at types of degrees and types of terms that are available. So let us take a look at a question here where we have 4x squared plus 3x. So let's see what the type of polynomial this is. Now, as per the degree, we can say that this is a binomial, right? Because the number of terms it has are going to be 2. So I can say that it is a binomial. And then the degree, the highest power here is 2. So I can say that by the degree, the name is quadratic. So the full name of the polynomial is going to be that it's a quadratic binomial. All right, let's take a look at our next one here, which is going to be 3x cubed plus 4x squared plus 7. So now you can pause the video a little and identify as to what type of polynomial it is going to be on the basis of the degree and the number of terms. So we can see that the number of terms here are going to be 3, 1, 2, and 3. So we can say that this is a trinomial. And then the highest power, so here this is 3, this is 2, and this is no power here of x, which is 0. So I can say that the highest power is 3. So the highest power 3, those type of polynomials are called cubic polynomials. So hence I can say that the name of this one is that this is a cubic trinomial. All right, let's move on to next one. This is x cubed only. There is no other term. It just is x cubed. So if it is just x cubed, what type of polynomial it will be? Just pause the video and think about it. So here we can see that there is no more terms. The only term is x cubed. So it is a monomial. Mono means one. Monomial. And then what is the highest power? So this is the only term. So the highest power is 3. And the polynomial with highest power 3 is called cubic polynomial. So we can say the name of this polynomial is a cubic monomial because it just has one term. All right, so other types of polynomials that we can see are also called constant polynomials. And constant polynomials are basically can be given as a constant number 1, 2, 3, 4. Like you have seen the numbers, at the end of the polynomial. Now, why do we call them polynomials? Constant polynomials, you might say that they're just constants. Basically, we can also write them as a polynomial. For example, 5, I can do as 5x to the power of 0. So they can be written as a monomial, hence, they are called constant polynomials because their value remains the same. It's a constant. All right, let's move on to the next one, which is going to be a zero polynomial. So zero polynomials are basically the polynomials whose value is 0. So the degree is going to be not defined because it's 0x to the power of 0. So, these are just zero polynomials, although you might not see them a lot, in your lessons that you study about polynomials. We are now going to move on to the next topic right under polynomials itself. So I'm going to just pick a nice color for you, and we'll start with this concept called the value of the polynomial. Value of polynomial. So in this one, actually, basically it is same as evaluating a polynomial. As you can see in evaluating also, there is a word called value. So basically the question that you could see is going to be of this type. Find P of 4 if P of x is x plus 7. So they are giving you a question here, something pretty simple here. You will see as we go ahead and solve it, that basically they are asking you to find P of 4. So here is P of x. So what you basically do is the value of x now becomes what? 4. So in place of x, you plug in 4. So wherever you see x in the polynomial, you put what? 4. So 4 goes here also and 4 goes here also. So how do we write our answer now? So our answer will look something like this, that P of 4 equals, now in place of x, what do I put? 4 plus, in the question, plus here, 7. So my now question, or the value of my polynomial with the new variable value, which is 4, becomes 4 plus 7. Hence, the value of P of 4 becomes 11. And that is my answer. So basically, what did you learn here? That you just have to plug in the value of the new value of x given to you into the polynomial. All right, let us take a look at another question of this type only, just so things are clearer to you. So we'll take a look at another question. Let's say it's question 2 on this section. They are saying P of x is 3x squared plus 4. And the question is, find the value of the polynomial at x equals to 2. So this is another way in which they can write the question. Instead of saying that find out P of 2, they are not writing it like this, but they are just writing a full sentence, but it's pretty much the same thing. So that's what they are asking. So now let us see how we are going to answer this question, or you can actually pause the video and you can start answering it on your own. So basically, like we shared in the last question, the new value of x becomes 2. So let's see how it will look like. P of x equals 3x squared plus 4. And now they are telling me to find out the value of P of 2. That means my new x value becomes 2. So wherever I have x, I will put what? 2. So let's see how that will look like. So here also I'll have 2. Here also I have 2 squared. So this should look an expression like this, 2. And then I need to bring a parentheses into the picture because I'm actually squaring the x. So I'm squaring the 2 here. So the parentheses will help me follow the right procedure, which is PEMDAS. And sometimes I have seen students say, okay, 3 times 2 is 6, and then they square it. So that is a wrong approach. Remember, in PEMDAS, what do? You do the parentheses first. So you have to do the parentheses first, which is going to be 3 times. Square of 2 is 4 plus 4. Now again, the parentheses is still here because we haven't multiplied these two yet. So we will now multiply. This is going to be 12 plus 4. Hence, my answer for P of 2, polynomial with value 2 for x, is going to be 12 plus 4, which is going to be 16. And that's my final answer. So that is the, answer for this question. And I'm going to give you a couple of questions for you to practice on your own. And they are going to be listed right here for you. It is still under the same section of finding the value of. So let us see what type of questions you'll have here. I'm going to give you 3 questions and we'll say find the value of each. And the first one is p of x is 5x squared minus 3x plus 7 at x equals to 1. Next one is q of y equals 3y cubed minus 4y plus square root of 11 at y equals to 2. And the third question in the same category, remember, finding the value of the polynomial or evaluating the polynomial, is 4t to the power of 4 plus 5t cubed minus t squared plus 6 at t equals a. This one is a little bit, I can say, challenging because the variable value is actually another variable. It's not a constant. So I want you to try this, and then basically you won't have a final answer for this. You'll still have an expression. You'll just actually substitute your t's wherever you have them, and you'll substitute them with a, and hence you'll get your answers. All right, next up we are going to move to the topic of, which is called the zeros of the polynomial. Zeros of polynomial. So basically, zeros of polynomial, you will see three words for this: zeros or roots or solution. So we always use this as a term, zeros or roots or solution, but they all mean the same thing. So let us first start with the definition of zeros of a polynomial. As to what is the basic meaning. So the definition is, zeros or roots or solutions are the values of x that make the value of the polynomial p of x equals 0. So zeros of polynomials are those values of x that will make the whole polynomial value equal 0. So what do we mean by that? Let us take a look at a little graph here to make more sense of this. So let us say we have a polynomial function here, which looks maybe something like this, So in this type of polynomial, the zeros or roots of the polynomials are basically going to be these values where it is crossing the x-axis, and as you can see, wherever it's crossing or touching or going through the x-axis, the value of y-axis on these, all of these values makes the y value to be 0. Hence, these are called the roots of the polynomials or solution of the polynomial or the zero of the polynomial. So I repeat, like this is the x-axis, this is the y-axis. These roots actually, what is the value of y here? Let us say this is positive 5 here for x. The value of y is 0. So x, that value is the root of the polynomial, which is making the y value on the graph equals to 0 for that polynomial. Or if I plug in 5 into the polynomial, I will get a 0. So let's take a look at what it actually means algebraically also. So still we are talking about the roots of the polynomial. Let us say we have the question or polynomial as px equals 3x minus 3. And they are asking you what value or what is the root of this equation. So think about it. What value of x will make this whole polynomial 0? So x has a certain value that I can plug in, which will make this polynomial whole value to be 0. So I hope you agree with me that if I put x equals to 1 here, then my polynomial will become 3 times 1 minus 3, which is going to be next is 3 times 1 is 3 minus 3. So 3 minus 3 is 0. So as you can see, the value x equals to 1 has given the polynomial value 0. So can I say that this is one of the zeros or the solution of the polynomial? Yes, I can say that this is the solution of the given polynomial. So I can say that x equals to 1 is the root or 0 or solution of the polynomial. So I hope that makes some sense to you about the basic information about roots of the polynomial. So let us take another example about the same thing here, about roots of the polynomial. So let us say we have another polynomial p of x equals 13x minus 13. So just pause the video and think about what could be the root of this polynomial, or what value of x is actually making the polynomial value to be 0. So there's only one value of x that I can take which will make the polynomial value 0. So I hope you agree with me that if I plug in 1 in place of x, the value of polynomial will end up to be 0. 13 times 1 is 13 minus 13. 13 minus 13 is 0. Hence, my polynomial value p of x is 0. And the moment p of x becomes 0, that value of x I can say is the root of the equation. So I can say x equals to 1 is the root or zeros or solution. Remember, these all three words mean the same thing, that it is the point where the graph is having the y value as 0. All right, let's take a look at another example, which is going to be something like, let us say we have another polynomial, now this time denoted by g of x. Let us say g of x is 1 by 3x minus 2 by 3. So 1 by 3x minus 2 by 3, I need to think about what value of x can make it to be 0. Now this is fraction, it becomes a little difficult. So in order to solve questions like these, what you can do is you can actually do 1 by 3x minus 2 by 3 and you can equal it to 0. Because anyways our polynomial will be equal to 0, isn't it? So that's why we are making the whole polynomial equation to be equal to 0, because we are trying to find as to at what value of x my polynomial is going to take the value 0. So what do I do here? Basically how we talk about in class is that x is grumpy whenever we are finding x. So we need to get rid of people around x, which is the first one is going to be 2 by 3, which is a negative 2 by 3. So I do the inverse of negative, which is positive. And hence I'll get rid of the negative 2 by 3 here, which will make me have 1 by 3x. This is gone over here, equal to, and 0 plus 2 over 3. 0 plus any number is the same number, hence I write the same number. Now I still haven't found x, and the number next to x is a fraction. So you can either use the numeric solve, or basically it is very simple from here. So what we are going to do is we'll do the opposite or reciprocal of this, and we'll multiply by the reciprocal on both the sides in order to solve for x. So this 3 and this 3 are gone, and 1 is basically 1x or x equal to. Now we can just solve these ones here. 3 times 2 is 6, and then 3 times 1 is 3, which can be further simplified to 3 times 2 is 6. So hence I can say that the value of x is 2, which I could not have solved it just by looking at the question. I had to do all of this math, to find the answer. That this value of x equals to 2, I can say if I plug it in into the polynomial, will give me 0 as the polynomial. Hence, I can say that this is the 0 of the polynomial. Remember the three terms we talked about? 0 of the polynomial, root of the polynomial, or the solution of the polynomial. So I hope it makes some sense to you, and I would like to give you another question for you to practice, where I would like for you to find the root of the polynomial. and you'll be showing your work in the notebook. Find the root of, so again with root I would like for you to understand the terms they could be using. Zero of the polynomial, so zeros or solution of the polynomial. And then the polynomial example is p of x is 3 by 7x minus 4 by 18. So this is the type of polynomial basically again with fractions. So just by looking at it honestly, I cannot find out what the x or what the root of the polynomial is. So what I'm going to basically do here is like we did in the last question. Remember, we actually put our polynomial equals to 0. So whatever you get in your polynomial question, you just put it equals to 0 because you're trying to find out what value of x is making the whole polynomial equals to 0. So this is your polynomial p of x. You're trying to put it equal to 0 and find the value of x, which will make it 0. Remember how we talk about it in classes that x is grumpy and you're actually trying to find the value of x and work it out and see what value of x actually makes your polynomial equal to 0. And just a hint that you'll get a fraction answer also, and you can leave it as a fraction. All right, now in this section of the video, we are going to talk about a very important concept called long division of polynomials. Long division of polynomials. So basically long division of polynomials, we are going to start with an example. Like we divide numbers, we also can divide polynomials with each other. We add them also, like how we add, numbers. We subtract them also, like we subtract numbers. And then multiply and divide them also, like regular numbers. But there's a set of things you need to remember in order to be able to do the operations with the polynomial. So let us do a question where it says find the remainder of. So let's copy the question. Find the remainder of when. Find the remainder when. What is the polynomial? 3x cubed plus 4x squared minus 8x plus 5 is divided by x minus 2. So here I would like for you to please highlight your longer polynomial and then the shorter one that we are dividing it by. So this is pretty much going to be like numbers only, but some, like I said, little strategies. So always remember, whenever we divided numbers, 2 times 4 is 8 is what we used to do. What do I multiply this by so I can get that number, right? That is a strategy we used. So we do minus 8 and we get a 0. So I just want you to remember some little things here that we used to do minus here. And these are the two things we used to do. What do I multiply this by to get the 8? And this part here was called remainder. So these are the things we are going to use here in this question also. So I want you to be able to understand them well. So let us now first set up our question. What do I mean by setup? By setup, I mean that my longer polynomial will go inside the division sign. And my smaller or shorter polynomial, or whichever they are saying is to divide it by, usually it is the shorter one, will go right here outside the division symbol. Now, I'm going to do long division method in order to find the answer or remainder for the polynomial. So in order to do that, what I'm going to do is, I'm going to choose this first one here, which is x. So I need to think about what do I multiply this x by to get a 3x cubed. What do I multiply this x by to get 3x cubed? So in order to do that, I'm going to have actually, what do I multiply this x by to get 3x cubed? So I hope you can agree with me that if I multiply this x by 3x squared, I will get a 3x cubed, correct? So that is what I'll put here as 3x squared. I repeat, I multiply this 3x squared by x to get a 3x cubed. I'm trying to get this inside term. So 3x squared times x gives me 3x cubed right here. Now whatever term I have here, I need to multiply it by this also, this term, the second term also. So this becomes 3x squared times negative 2 will give me negative 3 times 2, 6x squared. So I put it under the x squared term, which is 6x squared. Now, remember in division, we change the signs. So hence, I will change the sign here also. This is a negative symbol. I'm going to change the signs here also of the people. Whatever original sign they had, I do the opposite. So it was a negative 6. I changed it to positive. Now, this was positive 3x cubed. This is negative 3x cubed. They are gone. So I'm going to have a 0 here. But they are not gone here over here in this section. So what I have is going to be 6x squared plus 4x squared is going to be 10x squared. Remember, I don't add these powers. I just keep them as it is. Now this comes down minus 8x. Now I follow the same procedure again. What do I multiply this x by? X times what will give me? This time I'm trying to get this term, 10x squared. So I know that if I multiply x by 10x, I'm going to get 10x squared, right? So I'm going to write down plus 10x. And this gives me 10x squared, 10x times x, 10x squared. Now remember, whatever I multiply this by, I have to multiply it by the other number also. So positive 10 times negative 2 is going to be negative 20x, which comes here. Now remember, it's a division question. I need to change the signs. So I will change the signs to opposite sign. Opposite sign. Right. All right. Now I'm going to have, let us say this is gone again, which will I'll have a 0. Plus 20 minus 8x is going to be 12x. And now this 5 will come down and we'll use that 5 here now. We are still not done because we need to have either a number or 0. We'll see. We still have a term with x which we can work with. So now this time, what number do I multiply the x by to give me a 12x? So this is pretty little simpler than what we have done in the previous questions. We multiply this x by 12 to give us 12x, right? So that means my number here is going to be 12. Now 12 times x is 12x. This is what I wanted, so I could get rid of it. Remember, I changed signs also. It was positive. I changed it to negative. This is plus 12 times negative 2, which is negative 24. But remember, I need to change the sign, so I changed the sign to positive. The change sign, I'm putting them, like darker so you can see the difference. And here, this one is gone, so I have a 0 here. 24 plus 5 is going to be what? 29. Now, as you can see, there's nothing I have here to work with. So this part is going to be my remainder. So that is a remainder. And this part, what we have here is called the quotient. And this, what we are dividing by, is called the divisor. And this long polynomial is called the dividend. So the main important thing you need to know is going to be remainder as to what is remaining after the division, and the quotient, that's a part of the polynomial that we got after long division.